Complex numbers could be represented in rectangular form, and it could also be presented in polar form. In rectangular form is a plus bi, and in polar form we have two categories, that is trigonometric form and exponential form. How do we convert from rectangular form to a polar form? Before you can convert a complex number from rectangular form to a polar form, the first thing you should do is that you should first compute the radius and the argument. The only thing you need in converting from rectangular to polar is getting your radius and your angle. We already know that to find the radius is square root of a squared plus b squared, and finding the angle is also equal to tan inverse of b over a. And we've already known from the previous lesson that finding the angle, you must know where the complex number lies on the Cartesian plane, and that will help you to compute the angle. So after computing the angle and the magnitude, you can now go on and get your polar form. So in the polar form, we can have trigonometric form, which is z equals r cos theta plus I sin theta, and in the exponential form is z equals r e exponent I theta. Let's take an example. Let's consider this example. Z equals 2 plus bi. How do we change this to a polar form? To change this to a polar form, the first thing we need to do is we have to compute our magnitude, which is 2 squared plus 1 squared. That gives root of 5. Afterwards, we compute the angle. So our angle theta equals tan inverse of b over a which is tan inverse of 1 over 2. So the tan inverse of 1 over 2 gives a value of 26.57, approximately 26.57 degrees. On the Cartesian plane, this complex number z lies in the first quadrant. So that means our angle is the same 26.57. Since we have our r to be root of 5 and we have our theta to be 26.57, we can go on and find the trigonometric form. So the trigonometric form of our complex number becomes root 5 into bracket cos of 26.57 plus I sine of 26 0.57. So this is the trigonometric form. Now, to find the exponential form, we already have our radius and we have our angle. So we just have to substitute our values, and doing so gives our z in exponential form becomes r, which is root of 5 exponent this is how to express it in exponential form. Let's take another example. It's 3bi. We have 2, which is -1 plus 2bi. First of all, we need to, so taking the first example, 4 minus 3bi, the first thing we need to do here is that we have to find the magnitude or the radius, which is 4 squared plus 3 squared. That gives root of 16 plus 9, which is root of 25. And the root of 25 is 5. Let's see the angle. So the angle becomes tan inverse of 3/4, but we have to know the quadrant that it lies. The real part is positive and the imaginary part is negative, so it lies in the 4th quadrant. So to find the angle, that becomes 360 minus tan inverse of 3/4, 36.869 323 degrees. So we have our radius to be 5 and we have our angle to be 323 degrees. Changing this to the trigonometric form becomes, trigonometric form is r into bracket cos of theta plus I sine of theta. We have our r to be 5 into bracket cos of 323 plus I sine of 323. Finding the exponential form, which is r e exponent I theta, that one also becomes 5 exponent I 323 degrees. Let's take the second example. You can go on and try the second example. With the last example, we have -1 plus 2b the radius of z becomes root of 1 squared plus 2 squared, which is root of 5. Our angle becomes tan inverse of 2/1, which is tan inverse of 2. Tan inverse of 2 gives an angle of 63.43 degrees. We have to know the quadrant that our complex number lies. The real part is negative and the imaginary part is positive. So that means it lies in the second quadrant. So if it lies in the second quadrant, it's 180 minus, because it lies in the second quadrant, is 180 minus theta, which is 180 minus 63.43. That gives a value of 116.57 degrees. Now we have our radius to be √5. We now have our radius to be √5, and we have our angle to be 116.56 degrees. Now go on and express this in trigonometric form and in exponential form. So expressing it in trigonometric form, we have r into bracket cos of theta plus I sine of theta. That gives √5 multiplying cos of 116.56 plus I sine of 116.56, and in the exponential form becomes r exponent I theta, which is √5 exponent I 116.56 degrees. If you have any question, you can leave it in the comment section and we will attend to you. Thank you for watching.